So we're going to be going over some video objects that we created and what you can do with it in a language, and you can play back just like audio stream. You can just play back without seeing anything. Analysis, processing, those will be you getting the frames and what you can do with them. And then the underlying package that we're using is FFmpeg tools. So we're going to do some comparison as far as our functionality not against, but compared to what I have. So next. So there we go. So here is our nice looking objects. It's turn it down so basically that's a video that we get from the web. It's a simple simple GUI right now. Feedback's always nice. So we want to check to see whether that's a video, sure. And we have the Q function for it. We can get some information out of it, where it's located, because right now we only support out of core. There's no way we can fit that in memory. So there's a location for it, durations, frame rates, size, all the codecs. And we also have different kind of a GUI view for them. That's actually, we would like feedback on those GUIs. Oh wait, is it playing? So there are like YouTube kind of a GUI interface for it. Of course, you cannot do anything else other than pause and stop in this kind of GUI. Then we also have, there's a static one. Do we put this in? Oh, there we go. So that would actually open a system player. This is one of the things that we're trying to see how people like them.
Yeah, as I said in the previous talk, we support more video formats, video codecs than many players, including the default Mac player, which is QuickTime. So some things, but this is one idea for having a lightweight GUI that we show a static thumbnail, and then upon click, you can open the video in a default player as one option. I don't know. Maybe it survives, maybe not.
Yep. Do we have the summary one?
No.
Maybe not. So
Type 1, I don't know what summary.
So what do we have here? Oh, there we go. So we can have a stream that plays with it. Here you get most of them are static informations, like video tracks, number of tracks, currently where you are on the track device that you can output to. So the way to place those, and the way that you manipulate those is through properties, like the property of the streams. So we have a lot of property. Most of them are static. The only thing that's different is the current frame and the current positions. So then you can do dynamic on those guys. And then, of course, your video play. That should just play it, or and if you do a dynamic on the current frame, that you should just
play it again. Yeah, do that video play again.
Oops. Oh. Then move too far up. There we go. It's not coming down. Oh, probably my dynamic is taking over. Anyway, you can stop it, pause it. And then you can also change the currents. There's a property like current tracks for audio or video or a subtitle. So we can choose the equivalent track that you want. What else? That's on here. There's nothing on here. Oh, there we go. So then there goes the analysis part. And that's where she comes in. Oops. Here we go.
So yes, we introduced a video object. There are a couple of few functions that we introduced as a first step for analyzing and processing videos. In this talk, we decided we'll just show a few examples. If you have been in other talks, some of them may sound redundant, but these are basically to give ideas of what's possible now, what's coming next. This is a very simple operation like computing the mean intensity and then plotting it. And same thing, doing it channel-wise for all of the RGB channels. And all sorts of problems. And this is one example that I will run. This is a video. It doesn't have any audio. It's a musician playing guitar. For the first 8 seconds, there is one point of view. Then it changes to this view. It's smoothly moving, but so every frame is different from the frame before it. But then there are a couple of jumps. So there are 3 views that are being captured in this video, and this is the last view. If we look at them as different scenes, I can run this image distance on every 2 frames, moving on with 1 frame on that video, and I can very clearly see the 3 peaks that are telling me the times of each of those scenes. And we have a find peak function in the system that can correctly find the location of those. Then I can split the video on that times or do something else. We have processing as well. Video apply is one function that we have, which gets a function that gets an image in, returns an image, and creates a video object. So I've pre-processed most of these so that for the ones that they take time, we don't wait for the processing. But this is the negated version of the image. We could do other things, like for instance, here I have a video of 2 people interacting, one person sitting, the other one coming into the scene. And I'm running a little find faces routine, highlighting. Currently, we need to call rasterize, but we're going to support graphics and automatically rasterize it. So as in many applications, as you had seen, we can just highlight the faces that are detected on the image and show them in the video. One thing I mentioned in an earlier talk is the topic of annotations. We're going to be looking into how we can store the detected data from the video, store it in some kind of an annotation structure, not needing to bake the result of highlighting into the frames and writing it, but instead on the fly, highlight the video as well. This other one is the same thing. We have a video of a few people at a restaurant, a person serving them, and a very typical thing that objects are detected, people, cars, anything that currently are image cases, which is feeding image bounding boxes, can detect and highlight them on the fly. Whether you can do these real time on a video or no depends on the speed of the operation, obviously. Another thing, we have a street video semantic segmentation, for instance, is another one that you can run frame by frame. It doesn't need correspondence between multiple frames. But again, this is a result of a frame by frame operation applied to an image, to the video. And goes on. I'm using that musician example now that I have functions like video apply or video block map. Video block map I'm using to get the scenes, but then I decided I want some kind of an highlighting on either splitting or highlighting on the video. So what I'm doing is that I'm converting those times to frame numbers. Let me not run all of that, it may take time. And then I'm padding each frame number with 5 frames back and forth just to get bigger period of time. And I'm doing a very simple replace with red, which is that if statement. If the index of that frame matches one of these that I've detected, I'll replace that with a red frame, and I go on. Obviously, when I was prototyping this, I thought, okay, this is really some kind of a apply indexed kind of a function that might be useful to have, or a function that takes time as well as frames into account. So if we wait about 8 seconds to get to that scene change, we should change a red highlighting popping up. Then this is the second scene. Wait a couple of seconds for this scene to finish, another highlighting signal, and we'll get the last scene. Similarly, we can use the import-export capabilities that Piotr talked about earlier. Let me kill these as a prototype build just to make sure this is going to stay sane. To basically trim out, which is obviously should be, I think, a video trim, video split function. But I'm using that time to read all the video frames in and create a new video that only has that first scene in it. Obviously, if I had audio for this object, I could have just got that part of the audio from the original video and then export it into the video itself. The last example we are showing is an example that we released with the version 12 example pages. This is a key point-based stabilization. We basically have a video that is unstable. This stabilization problem is a bit difficult because the object that is the bubble is moving as well as the baseline, which is the ground. For this particular example, we are focusing on the bottom, which is the ground, finding all the key points, and stabilizing the frame by finding corresponding points, geometric transform from one frame to another, composing them, and then stabilizing the whole thing. But if I scroll all the way up, one thing that we obviously didn't highlight when we released 12 is that we are relying on import of file image list range of 80, which could be very large if you have a larger video. This one could fit into the memory, so fine. But if it doesn't fit into the memory, well, here I'm using exactly the same video, so it still fits. But I combined all of those operations like find geometric transform on the corresponding points and then compose transformation of frame 2 to 3 with the transformation of frames 1 and 2. And then that complete transformation is being applied to every frame using image perspective transform. So this operation is done. And on the video, frame by frame or 2 frame in, 1 frame out at a time. So it doesn't need a whole lot of memory except to be able to fit those 2 input frames and compute the output. And the same stabilization can be done on a much larger video. That's that. Chien-Yu, you want to take over the FFmpeg part? I can keep on going. All right, so not all of these are going to be super efficient because the frames are coming in. We are evaluating functions like color negate and so forth, which is color negate is fast, but then the operation might be a bit more sophisticated, time consuming. This is a very initial way that we hooked up FFmpeg, and we'll have to think how we exactly end up doing that. But a combination of these strings in a list form an FFmpeg filter, which is negating and LUT-RGB, I don't know what that, okay, it's negating basically RG and B and then putting them back together. So if I run this to show that this actually works as well as the color negate version that I was working before, this is basically the same negation but using FFmpeg filter rather than bringing frames into mathematical kernel and color negating them. The timings, we have a couple of them are going to be different. This is the FFmpeg timing is 3 seconds. The video apply color negate is slightly slower. We are thinking about ways of hooking up to FFmpeg and calling that. Maybe performance goal speed could be one option. Maybe a better syntax if a user cares for just putting in the FFmpeg filters there. Or maybe whenever we figure out that a FFmpeg filter is exactly identical to what we are doing, which should be the case in the case of simple things like color negate, I guess we just could call that up. Do I run dshake? So this is a deshaking filter that Chien-Yu found in FFmpeg, which we are trying to run. It's, oh, you wanted the bubble, right? Oh, that's why it took longer. Deshake itself doesn't have, or maybe does have any masking, or I don't know. But this one is trying to correspond all the key points that it finds probably in the image. And since the bubble is moving, it's not doing exactly what you want. So there is not going to be one-to-one correspondence, obviously, between what FFmpeg provides and what we provide. A few other examples of timings. We compared, for instance, the V-flip, which is a vertical flip, to our image reflect, almost twice faster. Edge detect, I think the default FFmpeg is not canny. Ours is. Bigger difference there. Image resize, which might be very, very useful if we want to show or provide a video GUI that is just showing a thumbnail and so forth. Also a big difference and so forth. So anyways, this is our backend. We just put it there to say that if you want to use it, it's there, and we are definitely going to be utilizing it. A very quick sneak peek to a few examples of what may be possible. Let's not bore you with more things. Thank you. Happy Halloween.